proiect cofinanțat de Uniunea Europeană prin Fondul European pentru Dezvoltare Regională în cadrul programului Interreg 5A România-Bulgaria. Conținutul acestui material nu reprezintă în mod necesar poziția oficială a Uniunii Europene.
ELINP stands for Extreme Light Infrastructure Nuclear Physics, so it's a research facility for nuclear physics which is based on the use of extreme light, and this extreme light can be defined in under two aspects. So on the one side we have a very powerful laser. We expect that the installation will be the most powerful laser system in the world. And also we'll have a very specific beam of photons, of gamma photons, which will be also the most advanced source of gamma radiation in the world, dedicated to nuclear physics. And these two main tools of the facility will help us investigate new aspects of nuclear physics, and not only nuclear physics, also quantum electrodynamics. Also we will have search for dark matter and dark energy, and of course we will have a lot of research dedicated to societal applications. For example, investigation related to medical applications, like finding isotopes, new isotopes for investigation of various diseases, and also studies for behavior of cells and tissues, and also electronics in mixed radiation fields.
The importance of ELINP is manifold. I will start with the scientific importance. A new center will be the most advanced center in high power laser in the world. So it's a science project, so we'll advance science to the border of knowledge. ELINP is also important because we hope to get involved in the society through the results in a more powerful way than Romania research is used, to change a little bit the mentality. So to have a lot of applied physics research results, and to try to implement them very quickly in the society. And related to this, the goal of ELINP project is also to gather around as many as possible high-tech companies to build a scientific park, and first steps are already done with Magurele Science Park cluster, where a few tens, almost 100 companies are together. So they are waiting to see if the high-level government administration in government position will push this idea to build a new scientific park around this new center. I cannot say that the results of the research performed at ELINP will be used only by the Romanians. Of course, that will be, if there are new technologies, will be transferred to industry, and we hope that the Romanians will benefit the most out of that, but this will be global anyhow. So we'll be part of this process of transferring results of research to industry, to companies, which will produce benefit to the society.
What do you say about risks?
Yeah, any research is dangerous. There are stories, and of course that the scientists working with that should take all the measures to not perturb in any way, in the wrong way, the society. I mean, nuclear physics experiments are well known since they started in 60, 70 years ago that you need radio protection. So all the experiments in nuclear physics are done in places which isolate the place, big walls, 2 meters thick walls, in such a way to not have any radioactivity released in the environment. In fact, the rule is that outside that building, the radioactivity to not be in any way different from the natural radioactivity. So in this way it's built also the center, LIMP. I will give another example because will be nuclear reactions inside and part of the air will be contaminated. In order to be sure that nothing is released outside, the building is in such a way that inside is a pressure which is a little bit lower than outside, that when you open the door, the air goes only in, not out. So the entire air inside is released only in a controlled way, going through filter, being measured, and only after the measurement and will be sure that there is no radioactivity in the air, is released outside.
Ce vedeți aici e un stand de testare pentru un ansamblu experimental denumit Gamma Above Neutron Threshold, sau pe românește radiații gamma deasupra energiei de prag. Mai exact, acești detectori sunt detectori de radiații gamma și de neutroni și vor fi instalați în ariile experimentale pentru experimentele ce vor fi instalate la sursa de radiații gamma. Deci, sursa de radiații gamma va produce un fascicul monocromatic de radiații electromagnetice de foarte mare energie, care vor iradia nucleele atomilor. Nucleele atomilor, în momentul în care sunt iradiate cu radiație de foarte mare energie, radiație electromagnetică de foarte mare energie, la un moment dat intră în rezonanță. La fel cum un receptor radio intră în rezonanță cu frecvența unui anumit post de radio. Când intră în rezonanță, dacă energia este suficient de mare, de-aia îi spune above threshold, deasupra energiei de prag, nucleul începe să emită neutroni și particule încărcate. Noi studiem care este acea frecvență de rezonanță a nucleului, detectând efectul rezonanței. Deci în momentul în care efectul devine foarte puternic, înseamnă că ne-am acordat pe frecvența, pe oscilația maximă a nucleului. Și înseamnă că am tunat fasciculul de radiații gamma încât să producem transmutarea nucleelor, să producem reacții nucleare cu ajutorul radiațiilor gamma.
I'm working on the project Gamma Beam in Nuclear Physics, and right now I'm testing silicon strip detectors for a LISA project. Supervisor is Catalin Matei. So we are going to set our silicon detectors inside of this barrel to measure during the experiment the nuclear reactions with the help of these detectors. So I'm checking does they work or not. I'm checking the strips, how they read the signals, and I'm measuring energy resolution on these detectors.
Nowadays, science concentrates around big facilities, and the idea is that scientists and university groups are mobile. They can come to such a facility, take their data and analyze it in their own universities. This allows to concentrate resources, to concentrate equipment, and in this way to attack the forefronts of science.
How important is to have scientists from all over the world in such kind of facilities?
Yeah, it's a natural way because to build such a facility, we want to have a team of the best, and the selection goes throughout the world. Science nowadays develops in a multicultural environment, And this allows to have different views and different ideas and exchange them from people which have different schools.
Of course, any big project, research project, as in LIMP, implies risks. So one of the main risks that the ELIMP was facing, it was the fact that the main equipments that are to be installed in the facility, so the high power laser system and the high brilliance gamma beam system, are putting technological problems and technological challenges that are beyond the state of the art of the technology presently available. So in developing and in building the two systems, the providers of the system had to develop also the technology that stays at the basis of these two equipment. There was, at the end of the stage one, at the end of last year, we arrived at a good moment when we realized that both providers of the two systems have overcome the two challenges. So they developed the technology necessary to achieve the parameters of the two systems that are to be installed at ELIMP.
What do you think about the role of such large-scale scientific infrastructure in development of a country? Could be an engine, is just scientific, or is more?
As General Manager Professor Victor Zamfir explained earlier, I think this institute purpose includes a basic science as well as application, for example, to the medical application, cancer therapy. So these ones is based on the most advanced laser in the world and the gamma beams in Romania will pull whole scientific community and the industry community in the future for Romania. So I think it's a very good opportunity for the Romania to line up in the first class of science and a very good, emerging possibility of industrial application.
Science in the last decades became larger and larger, so these large infrastructures are needed, large equipment, large teams of scientists. It's very unlikely that the next big revolution in physics will come from one single person. It's more likely to be the result of a successful combination of coherent combination of brain power. So I think this increasing size is needed for the science of tomorrow. And large-scale infrastructures should also mean, like we know from other examples in history, a very large development for the surrounding areas. So it's not an infrastructure isolated by itself, but it has to have a lot of synergies around and a lot of support from the society in general, from the industry, special technical for the technical aspects.
Let's say the risk is related mainly to the final goals of our installation. So we all hope that when we are starting a job, we plan to arrive to a certain level of functioning and operation of the devices. One risk is of course, that the science is not yet ready to reach that level.
But what about physical risks? The laser could affect our life, could penetrate the concrete and go in town.
No, so really the building was designed and built according to all the safety rules that are not only in Romania but also in Europe. So if you are looking around, you will see that the building has walls that are 2 meters thick, and this will ensure that no radiation, non-laser or nuclear will be possible to get out from the building.